Question number 64. f of x is given, which is equal to x square sine 1 by x when x is not equal to 0. f of x equal to 0 when x is equal to 0. We have to check the condition A, B, C, D, which one of is correct at x equal to 0. Let's see the solution of this question. So here f of x is given, which is equal to f of x, which is equal to x square sine 1 by x when x is not equal to 0, and f of x is equal to 0 when x equal to 0. First of all, we have to check the continuity at x equal to 0. Let's see. At x equal to 0, left-handed limit x tends to 0 to power minus. That means the value of x is slightly less than 0, which is approach to 0. f of x, which is equal to limit x tends to 0 minus. That means it's not equal to 0. Then we will take the function x square sine 1 by x. Now put x is equal to 0 minus h. H is the small value which is minus from 0, so that the value of the x comes less than 0. As x tends to 0 to power minus, we are able to write h tends to 0. Therefore, limit x tends to 0 minus x square sine 1 by x, we are able to write as limit h tends to 0. In the place of x, we are able to write 0 minus h whole square sine 1 upon 0 minus h, which is equal to, we are able to write limit h tends to 0 minus h whole square sine minus 1 by h, which is equal to limit h tends to 0 h square minus sine 1 by h. If you put the limit, then it will become 0 square minus sine 1 by 0. So we know that the value of sine 1 by 0 lies between minus 1 to 1. So which we are able to write 0 into minus 1 to 1, which is equal to 0. So left-handed limit, which we will get 0. Now we solve right-handed limit, that is limit x tends to 0 plus f of x. 0 plus means it's slightly greater than 0. Then we will take limit x tends to 0 plus, which is not equal to 0. So we will take the same function, that is x square sine 1 by x. Now we put x equal to 0 plus h. H is some small value, we plus with 0, so that we will get the value of x is slightly greater than 0. As x tends to 0 plus we are able to write h tends to 0. Therefore, limit x tends to 0 plus x square sine 1 by x, we are able to write this as limit h tends to 0, 0 plus h whole square sine 1 by 0 plus h, which is equal to limit h tends to 0, that is h square sine 1 by h. So, if you put the limit, you will get 0 square sine 1 by 0. So, we know that the value of sine 1 by 0 lies minus 1 to 1. So, this we are able to write as 0 into minus 1 to 1. So, this is obviously 0. Therefore, right-handed limit is also equal to 0. Now, f of 0 is already given 0. Therefore, we will get left-handed limit equal to right-handed limit, which is equal to f of 0. So, the function f of x is continuous function at x equal to 0. Now, we check the differentiability of function at x equal to 0. So, left-handed differentiable, that is limit h tends to 0 f of 0 minus h minus f of 0 divided by h, which is equal to limit h tends to 0 f of 0 minus h, we are able to write that is 0 minus h whole square sine 1 divided by 0 minus h, and f of 0 means 0 only divided by h, which is equal to limit h tends to 0, that is minus h whole square sine minus 1 by h divided by h, which is equal to limit h tends to 0 h square minus sine 1 by h divided by h. Now, 1h we cancel from here, then we are able to write this as limit h tends to 0 h minus sine 1 by h, which is equal to 0 into minus sine 1 by 0, which is equal to 0. So, left-handed derivative we will get 0. So, right-handed derivative we write limit h tends to 0 f of 0 plus h minus f of 0 divided by 0, which is equal to limit h tends to 0, we are able to write this as 0 plus h whole square sine 1 divided by 0 plus h, and we know that f of 0, that is 0 divided by h, which is equal to limit h tends to 0, we are able to write this as h square sine 1 by h divided by h, which is equal to 0 into sine 1 by 0 equal to 0. So therefore left-handed derivative equal to right-handed derivative, so the function f of x is differentiable. So till now we will get the function f of x is continuous and differentiable. So the option number A is not correct and option number D is also not correct. So our answer is B or C. For that we have to find f dash x and check the continuity of the function. So f of x, which is given, that is x square sine 1 by x. Now for finding f dash x, we use the product rule, that is x square the dx of sine 1 by x plus sine 1 by x the dx of x square. If we solve this, then we will get, that is x square, that is cos 1 by x minus 1 by x square plus sine 1 by x, that is 2x term. Now we cancel this with this term, then we write f dash x, which is equal to minus cos 1 by x plus 2x sine 1 divided by x. Therefore f dash x we are able to write as minus cos 1 by x plus 2x sine 1 by x when x not equal to 0, and f dash x equal to 0 when x equal to 0. Now we are going to prove the continuity at x equal to 0. Left-handed limit, that is limit x tends to 0 to power minus cos 1 by x plus 2x sine 1 by x. So put x equal to 0 minus h as x tends to 0 minus, we are able to write h tends to 0. Now this limit we are going to write as limit h tends to 0 minus cos 1 divided by 0 minus h plus 2, in the place of x we will write 0 minus h sine 1 divided by 0 minus h, which is equal to limit h tends to 0 minus cos minus 1 by h plus 2 minus h sine minus 1 by h. If you put the limit, then we will get cos 1 by 0 plus 2 into 0 sine minus 1 by h. We know that this value is from minus 1 to 1 and this term is equal to 0. So we are able to write this as minus 1 to 1 and this term is 0, which is equal to minus 1 to 1. Now similarly, right-handed limit we are able to write as limit h tends to 0 minus cos 1 divided by 0 plus h plus 2 0 plus h sine 1 divided by 0 plus h, which is equal to limit h tends to 0 minus cos 1 by h plus 2h sine 1 by h. After that we put the limit, then we will get minus cos 1 by 0 plus 2 into 0 sine 1 by 0. So which is equal to minus 1 to 1. Now we find f dash x at x equal to 0, which is equal to 0. So f dash 0, which is equal to 0. This is our left-handed limit and this is our right-handed limit. So left-handed limit equal to right-handed limit, but which is not equal to f dash 0. So f dash x is not continuous. So we will get f of x is continuous. F of x is differentiable and f dash x is not continuous. So option number B is our correct option.